The directions say to read the passages and answer the questions that follow. Then write a response to the writing prompt. Passage number 1. This is an excerpt from Packing for Mars, The Curious Science of Life in the Void by Mary Roach. Apollo 11 was the 1969 NASA spaceflight that first landed 2 human beings on the moon. Astronauts Neil Armstrong and Buzz Aldrin walked on the surface of the moon for about 2 hours collecting lunar material and planting an American flag. Paragraph 1. Of the millions of pages of documents and reports generated by the first moon landing, none is more telling, to me anyway, than an 11-page paper presented at the 26th annual meeting of the North American Vexillological Association. Vexillology is the study of flags, not the study of vexing things, but in this case, either would fit. The paper is entitled, Where No Flag Has Gone Before, Political and Technical Aspects of Placing a Flag on the Moon. Paragraph 2. It begins with meetings 5 months before the Apollo 11 launch. The newly formed Committee on Symbolic Activities for the first lunar landing gathered to debate the appropriateness of planting a flag on the moon. The Outer Space Treaty, of which the United States is a signer, prohibits claims of sovereignty upon celestial bodies. Was it possible to plant a flag without appearing to be, as one committee member put it, taking possession of the moon? A telegenically inferior plan to use a box set of miniature flags of all nations was considered and rejected. The flag would fly. Paragraph 3. But not without help from the NASA Technical Services Division. A flag doesn't fly without wind. The moon has no atmosphere to speak of, and thus no wind. And though it has only about 1/6 the gravity of Earth, that is enough to bring a flag down in an inglorious droop. So a crossbar was hinged to the pole and a hymn sewn along the top of the flag. Now, the stars and stripes would appear to be flying in a brisk wind, convincingly enough to prompt decades of moon hoax jabber, though in fact it was hanging less a flag than a diminutive patriotic curtain. Paragraph 4. Challenges remained. How do you fit a flagpole into the cramped, overpacked confines of a lunar module? Engineers were sent off to design a collapsible pole and crossbar. Even then, there wasn't room. The lunar flag assembly, as flag, pole, and crossbar had inevitably come to be known, would have to be mounted on the outside of the lander. But this meant it would have to withstand the 2,000-degree Fahrenheit heat generated by the nearby descent engine. Tests were undertaken. The flag melted at 300 degrees. The Structures and Mechanics Division was called in, and a protective case was fashioned from layers of aluminum, steel, and thermoflex insulation. Paragraph 5. Just as it was beginning to look as though the flag was finally ready, someone pointed out that the astronauts, owing the pressurized suits they'd be wearing, would have limited grip strength and range of motion. Would they be able to extract the flag assembly from its insulated sheath, or would they stand there in the gaze of millions, grasping futilely? Did they have the reach needed to extend the telescoping segments? Only one way to know. Prototypes were made and the crew convened for a series of flag assembly deployment situations. Finally came the day. The flag was packed, a 4-step procedure supervised by the Chief of Quality Assurance, and mounted on the lunar model, 11 steps, and off it went to the moon, where the telescoping crossbar wouldn't fully extend and the lunar soil was so hard that Neil Armstrong couldn't plant the staff more than about 6 or 8 inches down, creating conjecture that the flag was the most likely blown over by the engine blast of the ascent module. Paragraph 7. Welcome to space. Not the parts you see on TV, the triumphs and tragedies, but the stuff in between, the small comedies and everyday victories. Now we're going to read your second passage that you can use in your prompt. This is an excerpt from Pioneering Space Requires Living Off the Land in the Solar System by Bob Granith. The following article about efforts to send humans to Mars appeared on nasa.gov on September 30th, 2016. As NASA continues preparing for the journey to Mars, the technology now in development is expanding beyond the spacecraft and propulsion system needed to get there. NASA scientists and engineers are also developing systems to harness abundant resources available in the solar system to support these pioneering missions. The practice is called In Situ Resource Utilization, or ISRU. Like early European settlers coming to America, planetary pioneers will not be able to take everything they need, so many supplies will need to be gathered and made on site. The concept focuses on how to turn a planetary body's atmosphere and dusty soils into everything from building materials for shelters on Mars to rocket fuel for the trip back to Earth. Much of this work is taking place at NASA's Kennedy Space Center in Florida. Center Director Bob Cabana recently explained that the agency is moving to a new era in space travel. It was an incredible accomplishment when we went to the moon, said Cabana, a former space shuttle astronaut. We stayed for a couple of days and took some rocks home. We explored. Cabana noted that explorers leave a nice, safe environment. They go off to an extreme environment for a short period of time, gather information, and return. But now we want to be pioneers, he said. As pioneers, we will create a sustained human presence in an ever more extreme environment. Another need of deep space traveling astronauts is food. Dr. Joya Massa, a Kennedy Project scientist in the Space Center's Exploration Research and Technology Programs Directorate, researches food production in space. Food is something we all depend on, and it's not going to be easy to get food out of regolith, she said. Right now, we pretty much take all our food along to the space station, but seeds are very small. Seeds are easy to take. Massa has helped lead several successful efforts studying plant growth aboard the space station. There are a number of different types of plants we can grow, she said. We can start with produce that is just fresh, that you can pick and eat. Other crops, such as potatoes, can be added depending on available time and resources. NASA researchers on Earth and aboard the station are working to find optimum growing environments for plants and crops, including lighting, nutrients, and water, all while dealing with microgravity. As a Kennedy chemical engineer, Annie Meir is a part of a team developing a technology that could turn ordinary debris and other garbage accumulated by a crew of astronauts into valuable resources. There is food waste, there is biological waste, there is packaging waste, she said. Here at Kennedy, we're working on how to make this waste into useful products, such as methane for fuel. The trash reactor being tested at Kennedy can hold more than 3 quarts of material and burns at about 1,000 degrees Fahrenheit, about twice the maximum temperature of an average household oven. The end result is useful elements. Experiments have shown that 10 pounds of trash can be converted into 7 pounds of rocket fuel. Other valuable byproducts of the trash reactor include oxygen and water. It costs a great deal to launch a ton of payload beyond Earth orbit, Meir said, so why not reuse it? The resulting savings are significant. Making about 2 pounds of fuel on Mars saves about 500 pounds launching it from Earth to get it to the red planet. The greatest challenge for missions of a year or more is becoming Earth independent. Projects that focus on resource utilization are a part of ongoing efforts to do just that, moving from space exploration to pioneering. This is your writing prompt. You have just read 2 passages that aim to show the response of NASA to the challenges that traveling in space presents. Write a narrative that tells the story of someone who is a pioneer colonizing the moon. Be sure to use details from both passages in your narrative. Manage your time carefully so that you can plan your narrative and do some pre-writing using your scratch paper. You should use details from both passages and avoid over-relying on one passage. Your written response should be in the form of a multi-paragraph narrative. Write your essay on the lined paper provided.